We'll now take a look at the consultation worksheet question 4. For part 1, we are asked to find the vector m plus 2n. In this case, this is a very simple substitution of the column vectors of vector m and vector n. And for this part 1, we can easily obtain the answer as negative 317. As for part 2, we are asked to find the magnitude of a vector 3m minus n, which in this case we must first find the vector 3m minus n. Again, similar to the previous part, by performing a simple substitution, we can easily obtain our answer as 19.2. And with that, finding its magnitude, we apply Pythagoras theorem. So square root of 19 squared plus 2 squared, we'll get square root of 365, or 19.1 units to 3 significant figures. For part 3, we are asked to find the coordinate of t given that vector OT equals to vector nm times 2. So we can work out the right hand side of the equation, resolve the vector nm to be om minus on. Again, perform a simple substitution of the vector om and on. And then we will get 18, negative 8. Since OT is the position vector of the point T, therefore its coordinates will be 18, negative 8. Part B. The question actually gives us a few relations with regards to the length. So let's take a look at them one by one. OA equals to 3/5 of OP. We can label it as OA 3 units in length, AP 2 units in length. The second relation, AS equals to 1/3 of AB. We can then again label AS is 1 unit, SB is 2 units. And lastly, OR is equals to 5/4 OB. We can then say that OB is equals to 4 units versus BR equals to 1 unit. So the answer to part A, vector AB, we can simply resolve it using the position vectors of B and A, and the answer is simply B minus A. For part B, vector AS, if you were to look at the question, it has given us this information. Therefore, we can easily express vector AS as 1/3 of vector AB. And vector AB has been found in the part A, so therefore we can perform a simple substitution and express the answer as negative 1/3 A plus 1/3 of B. Part C, vector OS. Now, if we were to take a look at the diagram, it is clear to us that the vector OS can be found by joining OA then AS. So we can then say that the vector OS equals to vector OA plus vector AS. And for vector AS, you can see that we have obtained again from the previous part. Therefore, we perform a simple substitution. And we can conclude that the vector OS is equals to 2/3 of A plus 1/3 of B. Last but not least, for the vector PR, again, we adopt a similar approach, rewriting PR to be OR minus OP. And from the question, we realize that OR has some relationship with the length OB. So we can then proceed on by expressing OR to be 5/4 times of OB. And similarly for our OP, we have some relation that helps us to conclude that the OP is 5/3 times of OA. So therefore, we can then conclude for the vector PR, the answer is negative 5/3 A plus 5/4 B. And that's the end for part 1 of this question. Part 2. We are given vector OS equals to 2/3 of OQ, express SQ. Now the vector SQ, we can again adopt a similar approach by resolving it using OQ minus OS. And since we know that the OS has been found in our previous part 1, part C, therefore we shall tap on this answer. And with that, we can re-express OQ to be 3/2 times of OS and minus OS, therefore we are left with 1/2 times of OS. So substitute the answer that we have found in the previous part for vector OS. We can then find the vector of SQ to be equals to 1/3 of A plus 1/6 times of B. And that's the answer for part 2. Last but not least, we now ask to find the numerical value of the length PQ over PR. Now, it is clear to us that from the diagram, points PQR are collinear points. Therefore, it is good that if we are able to express PQ vector as a scalar multiple of PR vector. So with that in mind, we resolve vector PQ to be OQ minus OP, and individually, OQ equals to 3/2 OS, and OP equals to 5/3 OA. All these are obtained from the previous part of the question. And for the vector OS, again we tap on the answer that we have found in the previous part. And vector OA is simply A given by the question. We then are able to express our vector PQ as negative 2/3 of A plus half of B. And if we were to look closely, comparing this vector PQ to the vector PR that we have found in the earlier parts, we realize that it is possible for us to express PQ to be a scalar multiple of the vector of PR. And we now can conclude that the vector of PQ is actually equals to 2/5 of vector of PR. So with that in mind, in terms of length, we can also say that PQ is 2/5 times of PR, and that leads us to conclude that the ratio of the PQ over PR is 2:5. Now, upon obtaining this ratio, we can now reflect this ratio of the length on the diagram. PQ equals to 2 units and QR equals to 3 units. And this information is very useful for us to solve our part B. Area of triangle SPQ over area of triangle SQR If you were to study these two triangles very closely, you can easily find out that the length PQ and the length QR is their respective base. And we can also say that they have a common height. So to find the ratio of these areas, so for area of PQ, we can say that it's half times the base of PQ times the common height. SQR triangle is half times the QR base times the height. Simplify to PQ over QR and tap on the ratio that we have indicated on the diagram. The answer is 2/3.